This webinar, you will learn about how to use EBS Snapshots to back up your EC2 environment. We will review the basics of how snapshots work well, how to tag snapshots, cost tracking, as well as automate the snapshot creation process. We will describe some of the best practices and share some tips to give you some success as you use EBS Snapshots. Well, the AWS Storage Portfolio is really based on three core storage types: block, file, and object. Within block storage, we have EC2 Instance Store and Amazon EBS. Amazon EBS is designed for workloads that require persistent storage accessible by single EC2 instances. Typical use cases for Amazon EBS would include, boot volumes, transactional or NoSQL databases. Big data analytics platforms also use EBS, as well as a stream and log processing applications and data warehousing applications. Next, we have a file. So within file, we have Amazon EFS or Elastic File System. And it really provides a simple, scalable file storage for sharing data between multiple EC2 instances within the AWS cloud. And then we have object. So Amazon S3, some of you may be very familiar with this service, is an object storage service designed to store and give you access to just about any type of data over the internet. And then finally, we have Amazon Glacier. And this is an extremely low-cost, highly durable storage for long-term backups and archives. We also have data migration services that will help you migrate data into and out of the cloud. These could be offline services like Snowball or Snowball Edge, or they could be online services like Storage Gateway or EFS over Direct Connect. And we also have streaming services that would leverage, Amazon Kinesis Firehose. So what is Amazon EBS? So EBS is block storage as a service. So when, with an API call, you're able to configure a set of volume blocks with certain performance characteristics and then attach them to an EC2 instance. But keep in mind that EBS is not a disk. When you create an EBS volume, you're not getting access to a physical or logical disk. You're getting access to a service that delivers a volume or a logical volume that delivers a certain amount of volume blocks. And these blocks are a part of a massively distributed system, which has many, many storage devices. And you access these blocks over the network. Volumes are specific to an availability zone. So you must attach the volume to an instance in the same availability zone. They also persist independent of the instance. So you can attach and detach volumes to different instances, keeping in mind, though, that you can only attach the volume to one instance at a time. EC2 instances can have multiple EBS volumes attached to it, but each EBS volume can only be attached to one instance at a time. Each block associated with your volume is replicated within the same availability zone. You are only charged, though, for the blocks that you're allocated. You don't pay for these replicated blocks. It's just a part of the service. So because EBS is a service, it really offers us the ability to deliver a number of different features. And one of these features is service availability. So EBS offers 5 nines of service availability, and it offers a high durability rate. So the annualized failure rate for EBS is between 0.1% and 0.2%, which is nearly 20 times more reliable than a typical commodity hard disk drive, which has an AFR of around 4%. So just to put this into perspective, If you have 1,000 EBS volumes running straight for an entire year, you should expect 1 or 2 to fail. So often I get asked, well, what's the difference between EC2 Instance Store and Amazon EBS? Well, some EC2 instances have what we call Instance Store, which is local storage on the physical machine hosting your EC2 instance. EC2 Instance Store and EBS have some similarities. Both are presented as block storage to EC2. Both are available as either SSD or HDD magnetic spinning disks, depending on the type of EC2 instance. But that's really where the similarities end. EC2 Instance Store is ephemeral. Data stored on the instance store volumes does not persist beyond the life of the EC2 instance. So you need to think of it as being temporary storage. Data on EC2 Instance Store volumes is not replicated, but there's really nothing to prevent you from setting up replication yourself, setting up maybe a RAID volume, or replicating that data, say, to another EC2 instance. There's also no support to snapshot an EC2 instance store volume. So you would have to implement your own mechanism to back up data stored on an instance store volume. But with Amazon Elastic Block Store, or EBS, it provides persistent block storage volumes to EC2 instances. As I just mentioned, it provides 5 nines of availability, and the volume is replicated synchronously within the availability zone. There's nothing you need to do to set up this replication. It is automatic, and it's just a part of the service. EBS also supports point-in-time snapshots, and we'll dive deeper into what this means a little later in the webinar. EBS volumes are also elastic, meaning that you can change the volume type and performance characteristics live while you're using the volume, as well as increasing the size of the volume. Elastic volumes is a feature we released a few months ago. And if you're not familiar with how you can modify your EBS volume, I encourage you to check out the documentation or watch the deep dive webinar I did on elastic volumes back in March of this year. Instead of just offering a single SSD or HDD volume type, we give you a choice of 4 different volume types within EBS. 2 of them are based on SSD technology, and 2 of them are based on magnetic volumes or HDD technologies. In a few slides, we'll dive a little deeper into these 4 different volume types and their performance characteristics. EBS also enables auto recovery of EC2 instances. So what does this mean? So within Amazon CloudWatch, we have a metric called status check failed system for EC2 instances. And it's really a roll-up of a bunch of system checks that we do on your instance on your behalf to validate both the system and your instance. So if the system were to fail, this health check would fail and would trigger an alarm. And this trigger would automatically recover your instance. We would move your instance to a new piece of hardware and recover it automatically. So the instance would retain the same characteristics that it had prior to the system event. So that would be, the same IP address, the same instance ID, the volume mounts, everything would be the same. This EC2 auto recovery feature is available to all of our current generation instance types with EBS only storage. So as I mentioned earlier, EBS offers 4 different volume types. These are our current generation volume types. And it gives you really the best performance depending on your type of workload. You can select the best volume for your application. So for extreme IO-sensitive applications, which need consistent IOPS, we provide IO1 volumes, or it's also known as provisioned IOPS, where you're able to select the IOPS you need for your workload. This gives you the highest level of IO performance consistency, really an order of magnitude more consistent than other volume types. Following the launch of our IO1 volumes, we looked at the performance across our entire EBS fleet And based on our analysis, we designed the best suited volume type. So we launched the general purpose volume type, also known as GP2. And it's great for the majority of the workloads out there. That's really why we designed them the way we did. Last year, we released the ST1 volume, which is ideal for large block, high throughput sequential workloads, really being able to get up to 500 megabytes per second per volume throughput. We've seen a lot of excitement around our ST1 volumes from customers running big data or analytics workloads. And they were really able to get just as good or even better throughput numbers compared to our IO1 volumes, but at a substantial savings. We finally have our SC1 volumes, which is our cold volumes, and it is really a complement to our ST1 volume. It's great for sequential workloads like logging and backup. It has less throughput compared to ST1, but it's priced substantially lower. So it would be a good use for maybe a burstable workload like backups or even logging. So what are EBS snapshots? Well, you can back up the data on your EBS volume to Amazon S3 by taking a point-in-time snapshot of your volume. Snapshots are incremental backups of these volumes stored in S3, which S3 is really designed for 11 nines of durability, which is several times more, an order of magnitude greater than the volume itself. Snapshot pricing is based on the amount of data stored in your snapshot. It's really based on a per gigabyte per month. So in this example here, you would be charged 5 cents per gigabyte per month for snapshots stored in the US East 1 region or the Northern Virginia region. So our prices vary from region to region because our costs vary from region to region. But in our most recent price drop for EBS snapshots, we were able to lower our prices by 47%, which I know is great news for a lot of you on the line today. I want you to keep in mind, though, that snapshots are incremental. So when you take a snapshot, blocks that have changed since the last snapshot are backed up. Unchanged blocks are not backed up. So this helps lower your cost, as you're not paying for backing up the same unchanged blocks time and time again when you take a snapshot. So how does EBS snapshots work? Well, let's take a look at this. Say we have a new EBS volume and we've modified blocks A, B, and C. We then take a snapshot. So all of the blocks that have been modified since our last snapshot will be a part of snapshot 1. Because this is our first snapshot, that means all of the blocks that we've modified since creating the volume will be a part of snapshot 1. So all 3 blocks A, B, and C, are going to be backed up as S3 and will be a part of snapshot 1. Well, we continue to work and we modify block C. We then take a new snapshot, snapshot 2. Because block C was the only block that was modified since the last snapshot, it will be the only block associated with snapshot 2. And snapshot 2 is backed up to Amazon S3. Well, we continue to work, and now we modified blocks D and E. Then again, we take another snapshot. This is a question for everyone on the call today. What blocks are going to be associated with snapshot 3? Do we have any guesses out there? If you have a guess, go ahead and type that in the chat window. And if anyone answered A, B, and C, I think we're going to have to stop the webinar, go back, and start again. It is not A, B, and C. The answer here is going to be D and E. D and E are the only blocks that have been changed since the last snapshot. So only D and E are going to be associated with snapshot 3. So now that you sort of get the idea of how snapshots are incremental, what does that mean when it relates to snapshot retention? Does this mean that we can never delete individual snapshots? Otherwise, we risk losing blocks that we've never backed up as a part of another snapshot. So it doesn't. So when you delete a snapshot, you delete the blocks that are unique to that snapshot. If other snapshots are referenced, the same data, we preserve it. Well, what does that mean? That you need to keep the initial snapshot because maybe those blocks have never changed since? Well, no. So what that means is that, we're going to preserve those blocks for you. Well, let's walk through this example. Say that we want to delete snapshot 1. What do you think is going to happen? What blocks are going to be preserved? Well, blocks A and B are going to be basically moved over so that you can continue to, or you can be able to restore blocks A and B at a different time. Block C is really unique to snapshot 1 because block C was modified in snapshot 2. So we're able to recover block C. So if we delete snapshot 1, the only block that will be removed as a part of deleting snapshot 1 is going to be block C. So now that we sort of understand how snapshots work, how do we put them to work? How do we use them? So let's walk through a couple of scenarios. In this case, let's walk through a backup and DR scenario. In region 1, in availability zone A, we have an EBS volume attached to an EC2 instance. Our application is running and we modify blocks. We then take a snapshot, and those blocks are stored in Amazon S3. We continue to run our application, and the next set of blocks are modified, and they're going to be a part of snapshot 2, and so on and so forth. So we now have 3 snapshots with incremental blocks associated with each of the snapshots. Now that we have these snapshots, we need to present this data to another application in a different availability zone within that region. So from snapshot 2, we're able to create a volume and attach that new volume from snapshot 2 to an EC2 instance in availability zone C. So now that application has access to that data. We also have the ability to copy that snapshot to another region, or even perhaps share it with a different account. With snapshot copy, you can copy snapshots to different regions. You can also, if you want to share that snapshot with different accounts, you can do that as well by modifying the permissions of the snapshot and granting different AWS accounts permission to use that snapshot. Then they would use that snapshot to create their own EBS volume and get access to a copy of that snapshot data. Well, how else can we use snapshots? Well, we can use snapshots to build and share custom AMIs, or Amazon Machine Images. An AMI is essentially a template or a virtual machine of an EC2 instance, and it is stored durably in Amazon S3. There are many Windows and Linux-based AMIs publicly available in each AWS region, and they're used to launch instances quickly and reliably. So once you have an instance that is running, you can actually customize it. You can change the configuration of that instance. You can install additional software, and you can customize it to your needs. Well, say you want to then use that new customized machine and create an image that you can launch other EC2 instances from. When you create an image of an EC2 instance, you're actually creating an EBS snapshot of the root volume. You can optionally create snapshots of other volumes attached to that instance. And then you would use those snapshots to create AMIs of this customized instance, and then use that customized AMI to launch other instances in the same AZ or other AZs within that same region. Again, you can go ahead and copy that AMI to another region and then spin up instances based on that AMI in other regions for maybe backup or disaster recovery purposes. So how else can you use snapshots? Well, as I mentioned earlier, you can share snapshots with other AWS accounts. You can also make snapshots public. So in this case, there are some public data sets available out there for you to get access to. Some of the data includes, genomic or census, weather, or transportation information. All of these data sets are available to you as EBS snapshots with a snapshot ID, which you can go ahead and use to create an EBS volume from, so you could have access to this data set. You can also share your data to the public by just changing and modifying the permissions of your EBS snapshot. Well, tagging is an important feature that allows you to better manage your AWS resources. Tags give you the ability to really assign a simple key value pair to AWS resources like EC2 Instances, EBS volumes, and even EBS snapshots. This allows you to logically group resources together to help visualize, analyze, and even manage resources together. Activating tags for cost allocation tells AWS that the associated cost data and of these tags can be made available through the billing pipeline. So once activated, these cost allocation tags can be used as a dimension for grouping and filtering in the Cost Explorer. So here's an example of how you can create tags for EBS snapshots. Again, this can be done from the AWS Management Console or using the CLI or a simple API call. They're a simple key value pair. So as I mentioned, activating cost allocation tags from the billing dashboard allows you to get reports generated that has cost and usage data broken down by tags. This is also available from the Cost Explorer console as well. So this allows you to visually see what your logical groupings of AWS resources are costing you, including groups of EBS snapshots that are tagged accordingly. So if we look at this example, if all of our EBS snapshots were tagged as backup, then within our reports and Cost Explorer, we could see the cost and usage data associated with all of those EBS snapshots that were tagged as backup. So now that we have a deeper understanding of EBS snapshots, what they are, how they work, how we use them to back up and for DR purposes, how we use them to create volumes and create AMIs, and even copying them to different regions for DR purposes, even sharing them with different AWS accounts. How can we help you protect and automate the snapshot management of your EBS volumes? Well, we have over 70 plus different services available to you within AWS. These services are there to help you build integrated solutions. So some of these automated protection solutions that we have are EBS, for EBS snapshots, are really built using some of these services. And the three we're going to focus in on today is Amazon CloudWatch, AWS Lambda, and Amazon DynamoDB. So the first solution we want to look at is Snapshot Custodian. And this is a group of Node.js scripts that helps you manage the lifecycle of your EBS snapshots. All of these scripts are executed as Lambda functions and are scheduled to run using CloudWatch events. The first script, EBS Snapshot EC2, is used to create a snapshot from an Amazon EBS volume. This is a non-root volume identified by a tag that you define. The process will take an inventory of your volumes, and based on the tag, it will determine which volumes to snapshot. And even for Linux instances, it will do a sync command to actually flush memory to disk. And you can even further customize it to actually do a page flush. And there's even a bonus script as a part of this, included in this repo, that will freeze the mount point, snap the volume, and unfreeze the mount point or thaw the mount point so that the snapshot is consistent. And all this information, all this metadata associated with this process is stored in a DynamoDB table. The next script is basically monitors the state of the snapshot. and it's used to update the state field in the DynamoDB table, depending on what the state of the snapshot is after you create it. So we will go from, say, a pending state to a completed state. And if you schedule this CloudWatch event to run multiple times a day, it will monitor basically the life cycle of that snapshot as it goes from pending to completed. The last script is the delete snapshot script. And it's really used to delete each created snapshot after a certain period of time, a time that you specify. So you add a tag to your EC2 instance. And within this tag, you identify a value. Basically, the value is the number of days you would like the snapshot for a specific instance to live. This function basically calculates the number of days that has passed since you created your snapshot. And when the value of the days field comes up to the time it needs to, or when you need to delete that snapshot, it will go ahead and delete that snapshot for you. So you create a schedule to run on a daily basis. And if the retention number of days has expired for that snapshot, it will go ahead and delete that snapshot for you. So it helps you maintain this life cycle of EBS snapshots. The next solution I want to talk about is called the EBS Snapshot Scheduler. And it is a solution that automates also the creation and optionally deletion of EBS snapshots. It leverages EC2 resource tags and Lambda and DynamoDB, and it is really based on CloudFormation template. It is very cost effective. Really, the monthly cost of running this solution using the default settings in, say, US East 1 would run you approximately $1.85 a month. This doesn't include the cost of snapshots. This is just the cost of processing and management and scheduling the snapshot creation and deletion. Basically, those Lambda and DynamoDB charges. So within this CloudFormation template, you design and define different parameter values. So if you automatically want to delete snapshots based on retention day value, you would set that up within the template. You also set up the default snapshot time. Now, these values can also be overridden by values that you include in a tag. And again, this tag is a simple key value pair. You identify the tag that wants to be inspected when this process runs. And then there are certain values that you include in this tag. And these values are going to be separated by a semicolon. And the first value is identified as snapshot time. The next value is retention time. The next value is time zone. And then the last value is active days. So if we take a look at the first example in this table, the snapshot in this tag will be taken at 8 o'clock UTC time. It will be retained for 6 days, and it will be taken all days of the week. If we take a look at the next example, this one will be taken the snapshot will be created at 10 o'clock US Eastern time zone. It will retain 2 days of snapshots, but it will only be taken during weekdays. So this gives you sort of an idea of how the EBS Snapshot Scheduler will work. Really, the last solution then I want to share really complements the first two. It doesn't schedule snapshots. It doesn't manage the life cycle like the first two. But what it does, it monitors the creation of new snapshots and then copies them over to a different region for disaster recovery purposes. Again, this is really there it builds on the other two services that we just talked about. And this solution is also built on Amazon CloudWatch events and using AWS Lambda. So we've got a pre-recorded video that we'd like to share right now that will walk us through this scenario. So first, let's get our bearings set, and we're in the EC2 management console. We're looking at the EBS volumes, and we have a 100 gigabyte GP2 volume created, and we are in the US West 2 Oregon region. So if we take a look at our current snapshots, we see that we've already taken our initial snapshot, and we've named it Snap1. This solution uses AWS Lambda functions to initiate the cross-region copy of new snapshots. So let's go ahead and open up the Lambda console. The first step we need to do is create a new Lambda function. We'll start with a blank function and step through the wizard to get started. One of the benefits of using Lambda is that there's no EC2 instances to run or manage. We have our application code, which is a Node.js function that needs to be executed, either on a scheduled basis or maybe off of a trigger. So we'll give this function an intelligent name. We'll paste our code into the console. And there's two parts. This part here really does the copy of the snapshots. And then the top part, we identify the source and the destination of our snapshots. Each Lambda function has an IAM role or an execution role associated with it. So you specify the IAM role when you create the function, and the permissions you grant to this role determine what Lambda can do when it assumes this role. So in this case, we already have an IAM role created with a policy that will allow Lambda to call the copy snapshot API. We'll go ahead and accept these defaults, review it, and go ahead and create the function. Now that the function is set up correctly, let's go back and verify that the function is created. So we're going to be using CloudWatch rules to set up a rule that will trigger the function when a new snapshot is created. Now, this is very easy to do, and we'll step through the CloudWatch Create Rule Wizard. We don't want to schedule this. We actually want this to be triggered off in an event. So we select an event pattern radio button. We then scroll down and we select for the service name and the event name, EC2 and EBS Snapshot notification. We need to identify what type of event we want to listen for. So in this case, we want CloudWatch to listen for the create snapshot event. We will only want successful events. We don't want Lambda function to fire if the snapshot were to fail. We only want it to fire when it is successful. So now that we've defined this CloudWatch rule, we need to really identify the action that will be invoked. And we do this by creating and identifying a target. Here we will tell it to execute the Lambda function we just created, and it will run this Lambda function. So we select replicate snapshots function. We'll go ahead and give it the rule and name and give it a description. This function will copy newly created EBS snapshots from our US West 2 Oregon region to our US East 1 Northern Virginia region. We'll go ahead and create that rule. So now that we have the Lambda function created, we have the CloudWatch rule set up to trigger the function so that when new EBS snapshots are successfully created, it'll go ahead and copy that to another region. Let's make sure it's working correctly. So let's create a new snapshot of our volume in US West 2 Oregon. As you can see, the benefit of this is very simple. Within just a couple of minutes, we were able to set this up. So let's go ahead and we've created a new snapshot in US West 2. Now let's go to US East 1 to see what's happening on that side, if that snapshot is actually showing up. So we see that the snapshot is already being copied over to our US East 1 Northern Virginia region. And within just a couple of minutes, this snapshot is going to be available to use in a different region. So as you can see, we have a number of different solutions to help you manage the EBS snapshots. The first example that we went through, the snapshot custodian, is a little more complex, is a little more involved, but it gives you that bonus script to freeze and thaw the I/O so you can have consistent snapshots. The next solution we walked through, the EBS scheduler solution, is very easy to run. It's easy to configure. You run it, you create it using a CloudFormation template, and you manage it very easily by modifying the values of tags associated with your resources. But some things to keep in mind: it doesn't flush data to disk that could be cached locally, and it doesn't unmount or remount volumes. But then this last solution that we just walked through, the DR replication, really complements both the other solutions, where the snapshots that were created using those other solutions, you're actually able to copy them to a different region for DR purposes. So this really concludes the presentation part of today's webinar. And Joe, I turn it over to you for Q&A.